Steyn. Join me as I do interviews with leaders in the field of artificial intelligence from across the world. We speak about the business relevance of artificial intelligence, and we also speak about the future. Is it to be feared or to be embraced? Please subscribe at my website for updates on future interviews. My guest today is Ron Chrisley, the Director of the Centre of Cognitive Science at the University of Sussex. We had a very interesting conversation about his career in academia, including his time at Oxford University. And we also spoke about his time in Silicon Valley and Stanford and some of the well-known AI thinkers he studied under and befriended. We touched on artificial intelligence in education, about AI creativity, about when we may reach human-level intelligence, and also about the next generation of intelligent systems. Ron, thank you so much for joining me today. I was very excited to have this conversation. When I looked at your profile on LinkedIn, I immediately said I need to speak to Ron. Just some of the things that stood out for me: artificial creativity, wow; ethical issues, amazing; speech recognition, expectation prediction-based models, and then the other one, computational models of emotion. I mean, there's so much here to unpack, but it's like, wow. But maybe for the start now, Ron, just take us a bit through your career, especially your academic career, and then I definitely want to get into the work you're doing and also to talk about the future of this technology. So welcome.
Oh, thank you very much. It's a pleasure to chat with you today. When you list those topics like that, it can sound a bit pretentious, right? How can AI's only been around, some might think, for a few years. How could somebody have truly investigated all those topics in any level of depth in a few years? But of course, the informed viewer will know that the topic of AI research has been around certainly longer than I've been alive, and I got started early in my career. So while I was still an undergraduate, so we're talking 40 years ago, not quite 40 years ago, but back in the mid 80s is when I first started looking into these things. So that's why there could be so many different topics of interest investigated by one person, really. So it started, my interest in AI, although I had a philosophical interest in how the mind worked from a very early age. The field of artificial intelligence became a focus of mine and something that I knew I wanted to work in when I was an undergraduate at Stanford. And what was great about Stanford at that time in the 80s is even then it was one of the leading places of AI research, certainly in the US, if not the world. So there were opportunities, even as an undergraduate, to get your hands dirty and so I started by being a Lisp programmer on an AI project on a topic that I didn't really focus on much in the intervening years, but in the last few years I've come round to being interested in again, which is the role of AI in education. And I think we stand now at a point where we can really get quite good results in improving learning by humans. So when I talk about learning in this context, I don't mean like learning algorithms for machines, but how we can use learning algorithms in machines to model learners, that is humans, and optimize the kinds of content that they encounter and are exposed to and are challenged with in order to optimize their learning performance. So it's come full circle. But as you said, that circle involved a lot of other topics as well. But that's how things started at Stanford. And then I started with an interest in traditional, what's called GoFi, good old-fashioned AI, where you write Lisp programs and you try to encode knowledge that, say, a teacher might have, or you try to model the student in symbolic terms, but quickly saw that there was a limitation to that symbolic approach to AI. And I was influenced by, as so many people of my generation was influenced by writings from Douglas Hofstadter, who wrote not just this very influential book called Gödel Bach, but also his essays for Scientific American on the topic of AI really persuaded me that we needed to look elsewhere. We needed to look for sub-symbolic computations, or things that explained where symbols came from. And that's where I looked. That's why I switched my focus to neural networks and what was called connectionism then, or machine learning, that operated on a level lower than symbols, that could explain where the ability to represent symbolically came from. And that dominated my academic career for decades after that.
What I wanted to ask you is, when you were at Stanford, did you meet any of the people that we are now, that are famous now and are household names, the Google boys or anything?
Sure. Well, okay. Oh, well, the older generation of AI researchers were my profs, my tutors, my teachers. So people who know, certainly AI researchers and people who know AI personalities will recognize names like, my honors thesis advisor was Niels Nilsson, who recently passed away, and he was very highly regarded in the AI field. Also, Terry Winograd was one of my teachers, who is a big name in the history of AI, and quite famously turned his back on AI research because he thought it was going in a wrong direction, and particularly he was concerned about how closely allied it was with the military and the defense industry, and so he was worried about doing computer research in a socially responsible way. And he co-founded the Computer Professionals for Social Responsibility group. So just to pick two names out at random, but as far as the younger generation, so younger than me, the younger generation or similar generation that has made such a big impact, I would say that I was around at the same time as some of them. So like Elon Musk was there at the same time as me, etc. But the person who the most famous person in that group that you might know, that the people that your viewers will know, is not thought of as one of the main AI practitioners, but as somebody who is more influential in social computing, social networking, social media, and also venture capital, and that's Reid Hoffman. So Reid Hoffman was a good friend of mine at Stanford and Oxford, and I still keep in touch with him and pretty closely. And so that's one name from those days that some viewers will recognize. But no, I wasn't friends with Larry Page and Sergey Brin, and didn't know Elon Musk. But the same kind of climate that was shaping their thinking and their interest was also shaping Reid's and my interest in thinking, I think I can say.
Fantastic. Yeah, what an incredible university that is. And then from undergraduate days, take us to the following few years after that.
So, right, once I realized that neural networks and machine learning was the way to go, at least at that time, remember it's the mid 80s, late 80s, so there weren't a lot of people who'd been doing neural networks and machine learning for any length of time. There were, I knew Jeff Hinton, and I knew the name Jeff Hinton, I knew his work, I knew David Rumelhart. There were these people who were doing really interesting, great work in it, but I wanted somebody who'd been doing it for quite a long time to learn from them. And so I got a Fulbright grant to go to Finland to work with Teuvo Kohonen, who had been doing neural networks and machine learning since the 70s. Teuvo Kohonen had been doing neural networks research since the 70s, and from him I learned about the basic statistical models, basic learning models, what made neural networks an advantage in pattern recognition, when they were, and when they, what were the cases when they weren't. And also at the time that I was there, he developed one of his most it was a very influential algorithm called LVQ, LVQ2, when I was there, that really played a big role in the speech recognition industry for, I would say, the following at least decade, if not more. And it was only really put to bed and put to rest when the most recent successes in machine learning happened around 2010 or so. So I'd say for a couple decades, the work I did there was work that was frequently cited and of use to people doing statistical pattern recognition.
So you've also firsthand seen how it moved out of this academic domain, this kind of technology, to more of a commercial domain. Because from what I've read, for a long time, and maybe this is the case of a lot of new kind of technologies, it was a very academic, almost theoretical thing. And now it's just influencing everything we do. So what's your view on that transition? And I guess we're going to get to the future of this tech, but I think there's so much misunderstanding about what this technology is. There's still so much fear, and you can blame Hollywood for that to a large extent, I think. But the transition from academia to the real world, if you would, not that that's not the real world, but what has happened, and what do you think has maybe gone wrong, or potentially even gone right in the last few years, as most of us use this technology, whether we know it or not?
Right. So I definitely don't see it as having gone wrong. I mean, don't get me wrong. I certainly think there are challenges and there are concerns that we can have about how the technology is applied. And we can also have concerns about people overhyping what's been done. But by and large, I'm very excited and very positive about the technological developments that have happened in, say, the last 10 years. So rewinding back a bit to the late 80s, early 90s, there was a similar kind of hype there, because on paper, the people like myself and people who were back then, people who are on the forefront now, who were on the forefront then, like Jeff Hinton, they knew that the potential for these learning algorithms was very high. And so industry got interested and there was a lot of hype. But two things, as a lot of your viewers might know, two things weren't present at that time. So there wasn't the massive internet like there is now. So there wasn't as much data, and the hardware wasn't there. So the kind of the GPUs that you need in order to handle the large amount of data in any reasonable time weren't around. So things fizzled out, and there was a kind of backlash and a kind of second AI winter, or a kind of AI winter about these promises that the machine learning people, the neural networks people, had made back in the late 80s, early 90s. But they were right all along that these algorithms were set to transform how we compute. It's just that they were ahead of their time. We were ahead of our time in that the hardware and data weren't there yet. So now, moving forward, now that the data and hardware are here, and you have all that, you've unleashed the potential that a lot of people saw, or some small group of people saw back in the day for these algorithms, and I think that's like I said, largely been good. Now there are limitations though. So the people thinking that we've done all these great things with current models means that, well, we should have general intelligence in a few years, or we can just keep extending this, and we don't need any new conceptual revolutions or technological revolutions in order to get to, say, human level intelligence. I think that's a mistake, right? So this is just one very important tool in our toolbox that we will use when constructing the next generation of intelligent systems. But it isn't, the technology we have now is not the end of the process. We haven't cracked it yet, but we've made a very significant step in having these very successful statistical models that can be learned autonomously, that are very good statistical models of any particular domain.
So if I ask you, what does the next generation of intelligent systems, what will it look like? Where are we going on this journey?
Right. So it isn't the next phase won't be human level intelligence, but it'll be steps towards that. So I guess there are kind of three areas that I'm interested in pushing, or seeing intelligent systems develop along. And I guess one of them is right now, and there have been some good critiques of the systems we have right now, pointing out that we don't yet have this. So even though these systems we have are great technology for doing things, we shouldn't be fooled into thinking that they really understand the world that they're reasoning about. They're taking the things that we've said about the world on the internet, or taking pictures. They take pictures that we've taken and labels that we've given to them, and they can learn to correlate these very highly, so they can model how we use these things, words, concepts, or images. But they're entirely parasitic on our ability to do that. They don't have an understanding of the world themselves, so they don't even know what objects are. They don't, even if they can do a good job at identifying a picture of a cat, they don't even know what a cat is, right? So, and even if you got a good linguistic model that found what typical things people say about cats, that doesn't confer understanding. Just because they're able to predict that a human would give this answer to this question about a cat doesn't mean they even know what they're talking about when you ask the question, how many legs does a cat have? Even if you can predict the answer is 4, it doesn't really know what legs are or what cats are, right? So the one key step will be giving AI systems an ability to actually have some kind of grounded understanding of the basic aspects of our world, like objects and space and time and causation. So learning from the bottom what things are, and then you can add on this ability to learn the relationships between those basic elements in the way that we've seen, to take that kind of child level or animal level intelligence and then add to it this substantial ability to learn amazing statistics about those basic elements. And then you'll see a big revolution in the intelligence, even the perceived intelligence of AI systems. So that's just one dimension. I think related to that will be another important dimension, which is generality. And I don't necessarily mean the same thing as what people talk about when they say artificial general intelligence. When I talk about generality, I just mean not being trapped to one domain. So, AlphaGo plays Go, and maybe some other games you can modify to play some other games. But if you try to change the domain radically, it's useless. So AI systems in the next generation will have a general way of understanding what objects and space and time and causality are, and that will allow them to learn things about one domain. It will have basically a unified world. So the issues that come up when it's thinking about chess it'll be able to understand how chess is a game and how that relates to the people that it's trying to, say, optimize the work schedules for or something. So they won't be completely unrelated domains. They'll understand that there are connections between these activities and these entities. And I guess the final thing has to do with this topic that you mentioned I'm very interested in, which is creativity. So you could think of current machine learning as being a slave to the norm. The idea is to find out the statistics of what is the case and make sure you deviate from that as little as possible. Make the prediction that is the most consistent with the statistical norm, most consistent with the model you have. Minimize the error between what has happened in the past and what you expect to happen in the future. And that's really great and is an important part of intelligence. But there are aspects of intelligence that don't make themselves slave to the norm, that try to break the norm, that try to engage in activities or create things that are not understandable in terms of the previous statistics, but actually try to transform the norm and try to intervene on the norm and create a new reality. And I think AI algorithms or systems that are built with that in mind and try to actually take a model, but then in some way go against it in order to generate new possibilities that haven't been considered before, that will be provide a very powerful technology. It relates to the interest that I mentioned before of education, because if you can figure out what a learner's model of the world is, then you can try to suggest things that challenge that model so that they will be forced to adopt a new model that will be a better understanding of the world. I think it's at the heart of what we think of as intelligence, maybe even of what we think of as being conscious or aware, is this ability to creatively escape from the limitations of the model you currently have and embrace a bigger picture or a different picture, to reconceptualize the way things are, in order to allow for new possibilities, new solutions to problems that weren't even visible, weren't even conceivable before with the model that you had.
So much in what you've just said, Ron. I think things like causality, and awareness, consciousness. For me, a simple way of understanding it is AI is currently almost like my dog. I can train it to do certain things. It's got instinct, if you would, but it's a slave to me, I think. Where we're going, it's like my child, where I'm still teaching him, but he is now figuring it out. He's disagreeing with me. He's aware and conscious, which can result in great good, but also in great evil, because he can become a criminal. He can kill me one day, or he could really help me. So I think that's where, when we talk about this kind of next phase, is where a lot of the scaremongering, I guess, become relevant. Because what if this intelligence decides against us, or teaches itself things that we can no longer control? And I think, again, then the commercial and healthcare and educational possibilities are amazing. But are we going to lose control of this? Is this the end of the human race, if you would, as we know it?
Well, so I don't think we have to worry about the existential question yet, but it's good to realize that it is somewhere there on the horizon. But let me go back to the metaphor of, well, I don't know if it's a metaphor, but anyway, you're comparing our relationship to AI to our relationship with children. I think it's true that if we really did develop an artificial general intelligence, and certainly if we developed an artificial consciousness, then our relationship to it would no longer be like our relationship to any technology that we have. We don't have obligations to our technology. It's our ethics is all based about those creatures or organisms or whatever that have a stake, or that have some kind of, to which harm can be done, say, as an example. And once an AI system is truly generally intelligent, or once it's in effect a person, then it isn't our technology anymore, and we have to treat it like another person and have to respect it and take into account its desires and wishes, right? So that's very far in the future, and I'm just pointing out that the goal of making AGI, it might not be what most people really want to do. They don't really want to create something that is another individual with its own rights and responsibilities, because they do want to have control. They do want to use it as a technology. So you can't, I'm just pointing out that you can't it's inconsistent to want both. If you really want control and a technology, then you don't really want AGI. You want some of the features that AGI gives you, but you don't really want to create a new person. But going back to the crises, what kind of dilemmas we have about losing control of our technology. I mean, once you view it the way I suggested, then you'll realize our main concern is about AI technology is about how people use it. So our first concern, before worrying about it running out of, about us losing control of the technology, is we should be concerned about what will this technology enable people to do to each other, or what will it enable a government to do to its citizens, and will we lose control over that government, or will we lose control over those criminals? That's there is an issue of control here, and it does involve the AI technology, but it's not about losing. It's not like a Terminator scenario, right? It's more serious than that in a way, because it's more pressing. So that's the first thing I want to do, is redirect our attention to the quite serious ethical concerns that are not the Terminator scenario, but are even more pressing and more real right now and in the near future. Then Sure. Yes, it could very well be that moving, more towards what people have in mind about when they talk about losing control of AI. It might very well be that there'll be some algorithmic process that we could lose control over, in the sense that we don't. It's impossible for us to foresee the implications, and so it's not that we lose control in a Skynet type scenario again, or Terminator like scenario, but the thing is just so the implications of it for society and the economy are so big that there's no putting the genie back in the bottle. That's another thing we need to be concerned about. And it isn't necessarily blaming anybody. It's not like there's a bad actor, like a criminal or a government that's trying to use the AI in a bad way. It's just it has an undesirable effect on society, but there's no way to reverse the process. So that's another thing we have to worry about. And then finally, moving the one step more towards the kind of existential threat. People talk about the singularity and superintelligence, and sure, that would be really something to be concerned about were it on the near horizon. But before you even get there is the kinds of existential threats that you get from subhuman intelligence. You could have a very relatively stupid AI system that is not as smart as us, but because of how it's built and because of certain access we've given it, and because it's not spatially localizable, so you can't actually just put it in, whack it on the head or put it in jail or something like that, that it might be a threat. So you don't have to get to superintelligence to be a threat to humans. Like, let me just use as an analogy, like the gray goose scenario that people worry about with nanobots, right? You can have very stupid, very, very small things that follow some stupid algorithm, but if it's stupid enough and damaging enough, it could ruin everything, right? So there are these, it doesn't require superintelligence to be an existential threat to us. You could have, a matter of fact, it might even be more likely to be a threat to us if it can't reason through the consequences of its actions very well, and just blindly tries to produce paper clips, as to use the example from Bostrom's book, Superintelligence. So I think there's a whole range of ethical considerations as you get more and more, long before you get to the ones that are very far away. As you get closer and closer to our own time, there are more pressing ethical questions about how we as humans use and apply artificial intelligence. And I'm very glad to see that a lot of people are working on these more real ethical questions. And it isn't just that maybe the media tends to focus on the ones that are more science fiction like, but there are a lot of serious ethical researchers, a lot of serious business leaders, a lot of serious AI people who are looking at the very concrete pros and cons of introducing certain kinds of AI technology into different aspects of society. And I think that's very positive.
And before we end off, anything, well, there's most likely a lot, but what's exciting that you're working on at the moment? What are you thinking of working on in the near future, and maybe things like books or conferences, things we can look out for?
I can't say too much about the most recent project I've embarked on, but I will say that in a way I've already talked about it. So I do think, let me just say that I think one of the most exciting applications of an AI system that's able to enhance human creativity. I'm not just talking about AI systems that are themselves creative, but ones that can perturb us and prompt us in ways that get us to break out of our thinking, old thinking, into new forms of thinking. I think applying that kind of system to learning and education is very promising, and it's like, without going into any details, that's something that I'm hoping to work on more in the next few years.
Education is close to my heart, being a father of a 6-year-old, and I often think about what kind of job is he going to do one day, and what can I do from my side. So I've alluded to this on this video thing before, that when the lockdown started, I was homeschooling him, and I had to look at the school was quite good. They sent us files on Dropbox and videos, and but I was bored out of my skull, and so was he. So I decided we're going to stop that. So I downloaded a few very interesting games for him on his iPad, problem-solving games. And I saw much more of a benefit to him playing those games, and even just in his daily interaction, how he can solve problems better. And looking at this nonsense he got from the pre-primary school. And I know teachers are doing their best, but I think this topic of education in the future is something I think that deserves at least a follow-up call at some stage, Ron. It's close to my heart, and I know you can't talk about everything you're doing, but maybe in general, what can we do to better our education? And in poor countries like South Africa and rural areas, there must be ways we can do a better job to educate our children.
Well, just to say something concrete on that in closing, so I have a 7-year-old son, and he loves Minecraft, just like many other children of his age and older and younger. And that's great. I think it's great to have this kind of sandbox environment where you can be creative. It isn't the passive kind of game playing where you just choose between some fixed set of given options, but it's basically relatively open book, and you can spend your time in this world how you want to, and you can build things that, so it's great. It's like Lego it's like Lego in that way, only, has its pros and cons. But now imagine that you supplemented that with some kind of tutor who was there suggesting and challenging you to, so imagine the next step would be a fixed tutorial or a set of hoops to jump through to get you to learn to do various things in Minecraft, right? So instead of him having to do this on his own or watch videos of other people and how they've done it, instead, maybe he's given, built into the game are some hoops that get you to, like a lot of tutorials in a lot of games. But now imagine the next step is that the tutorial in the game was not one size fits all, but was keyed in to your interactions in the game, so it could assess what it is that you do know and don't know about the game, and what you have tried and what you haven't tried, and suggest challenges to you that will get you to break out of the way that you previously thought of what was possible before. That's a little bit along the lines of what I'm talking about. Although I hadn't before this conversation thought about Minecraft type games as an area of application, but maybe you're on something there.
Super. I like what you're talking about. I hated school. I felt it was so boring, and because of this one size fits all thing that you said, and I actually did fairly poorly. And it's only after high school that I started doing well in life and my career, because now I did things that I was really interested in. So if we can have some sort of an education system or application that really hones in on that individual child and what he or she is good at, and the best way for them to learn, rather than this monotone thing that we have at the moment, that would be amazing. So I look forward to see more about this into the future, and Ron, to follow your work. We spoke about important things today, and I wish you all the best, and keep us humans safe as we develop this technology. Thank you for your time.
Oh, thank you very much for giving me a chance to talk with you and to your viewers.